Hi class, this is the second part of the AP exam review 2, more probability, and we're going to be talking about random variables actually here. This is the second video, so please get your lesson ready. Means and variances of random variables. The mean mu of a set of observations is their ordinary average. The mean of a discrete random variable, that's one that takes on specific values, not continuous values, like weight would take continuous values. This takes on discrete values. The mean of a discrete random variable is also the average with an extra condition. The mean of any discrete random variable is the average of the possible outcomes weighted by its probability. So if you remember, let's take a look at this example. Linda is a sales associate at a large auto dealership. She motivates herself by using probability estimates for her sales. For a sunny Saturday in April, she estimates the following. On a Saturday, there's a 30% chance that she'll sell 0 cars, a 40% chance she'll sell 1 car, 20% chance of 2, 10% chance of 3. And if we want to find the average for this, mu, it's going to be, if you remember, you multiply these numbers, you multiply these numbers, you multiply these numbers, you multiply these numbers and add them, and that's going to be the weighted average. Okay, we denote the mean of a discrete random variable by mu sub x. So let me write that a little larger. So mu is the population mean, the mean for this woman, for her car sales, and that's the variable we're talking about, x. Okay. Another name for the mean of a random variable is called the expected value. So sometimes we'll say mean, sometimes we'll say expected value. So if you want to find the mean for this, you can multiply these, multiply these, multiply these, multiply these, and add those together. But I'll just show you, the calculator can do most of these computations for you. So if you go to second stat, no, that's not right. If we go to stat enter, you get your lists. We're going to put these numbers in L1, 0, 1, 2, and 3. We're going to put the probabilities in the second in L2, 0.3, 0.4, 0.2, and 0.1. And then if you go to stat calculate one variable statistics, L1 is your values of your variable. And in the frequency list, you should put L2. Second 2 is L2. Let's calculate that. And we see they're going to call it X bar because they don't know that it's a population parameter. So, but mu sub x is going to be 1.1. And also bear in mind that if you need the standard deviation or any other statistics from that this particular statistic, from this particular set of data, you could get it there. So we found out that X bar is 1.1. So that means that on average, she sells 1.1 cars on a typical Saturday. Okay, the variance of a random variable. The variance and standard deviation are the measures of spread around the center of the distribution. We use a special symbol to denote the variance of a random variable. And I'll write it a little larger over here. It's sigma squared sub x. This is the variance, and that's for whatever variable you are talking about. You could actually even put the name of the variable here, car sold or whatever. We'll call it x for now. The variance is calculated in a similar way to the way we did it at the very beginning of the course. Like the mean of a random variable, we also use a weighted average to calculate the variance. Now, this is the formula you would use, but you would really never have to compute it yourself. You could put the values into your L1, L2. Don't forget to put frequency list as L2, and it will compute the variance. Actually, it gives you the standard deviation. If you want the variance, you'd have to take the standard deviation from the calculator and square it. Okay? Okay, now we're going to talk about transformations. Let me put something under here. We're going to talk about transformations of random variables, operations on random variables, transformations. Now, what we mean by that is in the case of Linda and her car sales, if Linda makes a certain amount of money per car sale, let's say the number that we're going to get from the next problem is she gets $350 for each car. So multiply 350 times 1.1, you would get her the amount of commission she would make. Okay, so let's take a look at the types of transformations we could do. First of all, if you want to find the sum of two random variables, like we're going to do in a few minutes when we add Linda's car sales, plus we're going to take a look at her truck sales, we would simply find the sum of the mean of the two random variables. If you want to find the difference of the two random variables, you simply do the difference of the means of the two random variables. So if you want to see, again, we'll use a different example. Suppose the average income for a man in her department was $600 per day, and let's say her average is $500 per day, then the difference would be 100. You just simply subtract. Now, here's something new, and this is important. If the random variables are independent of each other, let me just highlight that because it's important. The variance of the sum or the difference is always the sum of the variances. So if you want to find the variance of the sum of two random variables, the sum of the variance, you would just add the variances together. If you're doing the difference of two random variables, you still add the variances together. You don't do a difference of the variances. It's always adding the variances. Now we could do other transformations like I talked about. If you wanted to find out how much Linda makes per car, we can then multiply by that single number, like $350 per car. So combining normal random variables is if x plus y are independent normal random variables and a and b are any fixed numbers, like again, let's believe a is Linda's commission for a particular for a car. So let's say it's 350. You could literally just multiply 350 times x, and we're going to look at her truck sales. I think she makes $400 per truck. Let me look at the next page. Yeah, $400 per each SUV or truck, $400 times the number of trucks she sells, and that new variable, ax plus by, is also normally distributed. Now to do the transformation on the standard deviation, you cannot do it directly on the standard deviation. You would have to do it on a variance, and we'll take a look at how to create the variance for such a random variable. We'll look at that in a minute, because let's actually take a look now at a particular example. So this we saw already. This is Linda's car sales, and now we see Linda's truck sales. So we could put this data, I can go back to stat, enter. I'll clear out these lists. Actually, this one, I'll clear it out too. So she sells on a Saturday either 0, 1, or 2 trucks. The probability of each of those, for 0, it's 40%. For 1, it's 50%. For 2, it's 10%. And now I can go to stat, calculate one variable stats. L1 is the variable data, and L2 is the probability. And we get that y bar. This is going to be variable y. This is variable x. We knew mu of x from before, that was 1.1, and the number we just found here is 0.7. Also, I'm going to write down over here, we'll save this for later, I'll write down the standard deviation for x for car sales. That I saw from before was 0.943, and the standard deviation for truck sales, you could see it is right here, it's 0.64. We'll use that later. But right now we're going to take a look at how we can do this transformation, how we find out how much money on average Linda should make, her expected commissions for a particular Saturday. So her commission rate of 25% of gross profit on each vehicle she sells. Linda expects to earn $350 for each car sold and $400 for each truck sold. Let me just do one more thing. Yeah, I'm going to put something here so it doesn't bleed through. Okay, so this is how much money she would make. 25% is kind of irrelevant. They're telling you how much money she makes per car sale and how much money she makes per truck sale. You would simply do 350 times the expected number of cars she sells plus 400 times the expected number of trucks she sells, and that means that she should expect to earn $665 on a given Saturday. Okay, let's talk about the variances for Linda. let's talk about the individual variance. What's the variance for the car sales? Well, the standard deviation is 0.94, so we would have to take that standard deviation, which is 0.943, and we would square it. So the variance is 0.889. We could do the same thing, and I'm not going to show you the details here. The variance for y is 0.7 squared, and that's going to be 0.41. So how do we get the combined variance for this new variable z? Okay, so to find the combined variance for z, which is this variable, you would, and keep in mind, these numbers are squared numbers, but the 350 and 400 are not squared numbers, so you would take the 350, square it, then multiply it by the variance for x. Remember, this is all on x here. We're doing a 350 times 1.1, but because this is a variance, it has to be 350 squared times the standard deviation squared, or, which I've already done, which is the variance 0.889. Remember, you can't do any operations directly on the standard deviation. They can only be done on the variances. We do the same thing for variable y. It's going to be 400 squared times the variance, which is 0.41, because that's already a squared number. And that equals 174,502.5. That's the variance, and if you want the standard deviation now, you can get it by taking the square root of that number. The variance for that is 417.7. So basically, the average amount of money that Linda would make on a given Saturday, an expected value is 665 with a standard deviation of 417. So if you take 417 away from that, it wouldn't be unusual for her to make something like $250 on a particular Saturday, but also it's possible that she can make over $1,000 on a Saturday. This is the expected value, but it's not the actual value she makes. There is a standard deviation. This is not true. Sorry. There should be no squared there. That's a variance. Standard deviation is 417.7. Okay, that's video number 2 of 3. I'll be putting up video 3 soon.